So this third level that I'm talking about cannot be achieved in exam hall, and I don't think so it will be asked in exams, because this just does not need a lot of observation or intelligence like that. It also needs more data from sources. But we are not in exam hall, we are in our home with internet connections, so we can know pretty much everything. Let's see what this method is about. Okay, so since this level needs high precision and accuracy, we will be using this figures right in over here. These the sources I will give in the description. So firstly we will calculate using this, then we will talk about the concept and how to use it. This will be equal to, now we'll be doing this calculation through these values which are experimental values, and let me show you calculator. We have 1 mole of ethanol, which will be, since the molar mass of ethanol is 46.06844, and since we want its volume, we'll just divide this with the density, which is 0.78506. Awesome. Now we have to add to this the volume of water, 24 moles of water, so that will be like 24 times the molar mass, which is precisely 0.01528, and this one will be divided with density, which is 0.99708, and yeah, that's pretty much it. It's 492 point this long number. So I'll be writing this in the notes. Okay, so from calculator we can say that this is equal to 1 over 492 point whatever that number is. I'm not writing it, it is saved in calculator. Now you might be like, all you have done is just use more accurate values, there's nothing new in this. And that new thing is this graph. What does this mean? To understand this, I want you to have a look at this equation right over here. Is this equation, think about it very deeply, is this practically correct? Let me give you an example. If we took some amount of water, added some amount of sugar in it, it just dissolves. The sugar dissolves. Where does it go? It goes into the intermolecular spaces of water molecules, right? So whenever you are adding ethanol and water to create a solution, some amount of ethanol will occupy the space of molecules of water, and the exact volume of solution will be slightly less than it, and that is what we can get from this graph. This is a graph, it's an experimental graph. It's about excess volume of ethanol per solution. You can see that this excess volume is in negative. These things are the mole fraction of ethanol. So when mole fraction of ethanol is 0, that is when there is no water, that means when there is no ethanol, there is just water. If you took 1 liter of water, the total will be 1 liter. However, suppose you took like 0.30 fraction of ethanol and the remaining, which is 0.7, water. If you add it, then you will have to subtract like this and this, about minus 1 from the original value. This minus 1 is centimeter cube per mole. That is the amount you will have to subtract. So what this plot is essentially telling us is, suppose you have 1 milliliter of ethanol, you add it to 5 milliliter water, total will be 6 milliliter minus some amount which is of ethanol, which is occupied into those previously empty spaces of water, intermolecular water, of those empty spaces between the water, right? That's what this graph is telling us. So we will have to subtract that to get the most precise or the most satisfying result, I would say. So how do we find that x, or the value to be subtracted? X is volume. What was the original mole fraction of ethanol from the question? Can you recall it? It was 0.04, so it will be somewhere over here. Okay, and it's very hard to see what that point is, so I have plotted the same graph in Desmos. Have a look at there. Here we are in the Desmos with the curve that was previously shown to you, and we have to find out the value of this curve at the mole fraction of ethanol was 0.04. So I just have this in equal, so just turn this on, and the intersection point will be our value. It's minus 0.1889, and if you remember, we have to just subtract this value or add this value, since it's negative, into our previous result. Our value was minus 0.1889, so that gives the value to be 492.1254. Let's add that to our notes. So from the calculator and Desmos, we can say that this is equal to 1 over, the value comes out to be 492.12 something. And now to get this, we can, and this value will be in centimeter cube. We want it to be in liter, so we will go to the calculator for one last time. All we have to do is take this value and divide this by 1000 and take its reciprocal, and that gives us the value to be 2.032. So we get the final value to be 32. This is our final answer, and this is 2.032, and this one was 2.3148. It's not that I have lost accuracy, I just was lazy to write the next digits since they are 0, 0 anyway. So this was an interesting question,